New Syllabus Mathematics Book 2 Exercise 1A Question number 12 from this exercise. The net force F newtons needed to push a block along a horizontal surface is directly proportional to the mass m kilogram of the block. When m equals 5 kilogram and force F equals 49 newtons, then find an equation connecting force F and mass m. Second part from this question is to find the value of force F when mass m equals 14 kilogram. Third part from this question is to calculate the value of mass m when force F equals 215.6 newton. Last and fourth part from the question is to draw the graph of force F against mass m. As we know that in the statement of the question, force F newtons needed to push a block along a horizontal surface is directly proportional to the mass m kilogram. So since force F is directly proportional to mass m, so this statement can be written as F is directly proportional to mass m. If we remove this sign of proportionality, then we place constant k, then this equation becomes F equals km. To find constant k, this equation becomes force F upon mass m equals constant k. Since we have given the value of force F 49 and mass m equals 5 kilogram, so by putting these two values of mass m and F 49 in this equation, F upon m equals k, this equation becomes 49 upon 5 equals k. Okay, if we divide 49 by 5, we get 9.8 equals k, which is the value of constant k. Okay, to write the equation connecting force F and m, we are going to put the value of k, which is 9.8, in this equation F equals km. So this equation becomes F equals 9.8 m, which is the required equation connecting F and m. Second part from the question is to find the value of F when m equals 14. So I'll be taking this equation because force F is directly proportional to the mass m, so F equals km, and we are going to put the value of m and constant k, which is 9.8, in this equation F equals km to find force F. This equation becomes force F equals 9.8, which is the value of constant k, multiplied by m equals 14. By taking their product, 9.8 multiplied by 14, the product is 137.2, which is the required force to push a block of mass 14 kilogram. Now third part from the question is to calculate the value of mass m when force F is 215.6 newton. So once again we are going to use this equation where F equals constant k multiplied by mass m. So we have given the value of F, which is 215.6, and this equation F equals km becomes 215.6 equals constant k, which is 9.8 multiplied by m. Again we are finding m, so let's take this 9.8 to the left side. This equation becomes 215.6 over 9.8. Now dividing 215.6 by 9.8, so these two numbers are the multiples of 2, so we get 1078 upon 49. Since we have same number of digits in the decimal part of numerator and denominator, so we can remove this decimal point without any changing. So this number becomes 2156 upon 98, and when you divide numerator and denominator by 2, so we get this number 1078 upon 49. Okay, now this number 1078 over 49 is the multiple of 7, so let's divide these two numbers by 7, so we get 154 upon 7, and finally 154 and 7, Again, they have same common factor 7, so let's divide them by 7. So 7 times 1 7, and 7 times 22 equals 154. So the required mass is 22 kilogram, and the required amount of force to push this mass is 215.6 newtons. Next, fourth part from this question is to draw the graph of force F against mass M. So I'll be taking this equation, which is F equals Km. So first value for M and F, let's calculate. Okay, let's take M, mass M equals 0. If mass of the block is 0, then the required force will be definitely 0. So this 0 can be calculated by F equals 9.8, which is the value of constant K. Since we have 0 M, so I'm going to replace M by 0, so 9.8 multiplied by 0 equals 0. Okay, for the second value of M, M equals 1, let's calculate F, the required force. So 9.8 multiplied by M equals 9.8. So 9.8 Newton force is required to push the block of mass 1 kilogram. And when M equals 2, then the required force F can be calculated by using this equation, F is equal to Km, where K is 9.8 and M equals 2, so 9.8 multiplied by 2 equals 19.6. And when M equals 3, then the required force F equals 9.8 multiplied by 3, and their product is 29.4 Newton. Another value of M, if M equals 4, then the required force F can be calculated by 9.8 multiplied by 4 equals 39.2. So now let's write these values in the form of ordered pairs. So when M equals 0, force equals 0, so first ordered pair becomes 0, 0. And when M equals 1, then the required force F equals 9.8, so the second ordered pair becomes 1 and 9.8. Third ordered pair 2 and 19.6. Fourth ordered pair becomes 3 and 29.4, and the fifth ordered pair becomes 4 and 39.2. Okay, let's plot these ordered pairs on a sheet of graph paper. So here is the graph paper. Two axes are given, horizontal axis and vertical axis. I am going to take mass M on horizontal axis and force F on the vertical axis. And here's the suitable scale. I will take 1 large square equals 1 kilogram on the horizontal axis. It means 2 large square equals 2 kilogram, 3 large squares 3 kilogram, and 4 large square equals 4 kilogram. Same as on the y axis. On the vertical axis, I'm going to take 2 large square equals 9.8 newtons. And then 4 large square becomes 9.8 plus 9.8 means 19.6 kilometers. And then 6 large squares equals 19.6 plus 9.8, 29.4. And 8 large squares equals 4 and 39.2. Okay. First order pair 0, 0. When mass M is 0, then the required force is 0 Newton. So this point of intersection, here we have the point of intersection for 0, 0 ordered pair. The second ordered pair is 1 kilogram mass, and the required amount of force is 9.8 newtons. So this is the point of intersection between these two numbers. And when the mass is 2 kilogram, then the required force is 19.6 newtons. So this is the required point of intersection for these two numbers. Same as for 3 and 29.4 is this is the required point of intersection. And for 4 and 39.2 we get the point of intersection over there. So if we join these point of intersections, we get a straight line, which is the required graph of force F against mass M. That's it for question number 12. Next question is question number 13 from this exercise 1A. The pressure P pascals of a gas in a container is directly proportional to its temperature T Kelvin. When temperature T equals 10 Kelvin, pressure P equals 25 pascals. Again, we have two different quantities, temperature and pressure. So we'll be finding an equation connecting pressure P and temperature T. Second part from the question is to find the value of pressure P when temperature T equals 24 Kelvin. Third part is to calculate the value of temperature T when pressure P equals 20 pascals. Last part is again to draw a graph of pressure P against temperature T. So same steps which we have done in question number 12. Since pressure P is directly proportional to the temperature T, so P is directly proportional to T, and when we remove this proportionality sign, we will place constant K. This equation becomes P equals constant KT. So first of all, let's find constant K, then equation becomes P upon T equals constant K. And since we have given the value of temperature and pressure, which is 10 and 25, so by putting these two values in this equation becomes 25 over 10, and if you divide 25 by 10, 2.5 is the required quotient. So constant K equals 2.5. So after finding the value of constant K, let's write an equation connecting pressure P and T. The required equation is P equals K, which is 2.5 T. Second part from the question is to find the pressure when temperature is 24 Kelvin. So again the same equation where P is directly proportional to the temperature T, or P equals KT. I'm going to put the value of K, which is 2.5, and the value of T, which is 24. So KT means 2.5 multiplied by 24, the product is 60. Next part from the question, third part, is to find temperature T when pressure is 12 pascals. So again the same equation, P equals KT. By putting the value of P and K, this equation becomes 12 equals 2.5 T. To find temperature, I'm going to take 2.5 from right to the left side. And this equation becomes 12 upon 2.5 equals T. And dividing 12 by 2.5 equals 4.8. It means that if pressure is 12 pascals, then the required temperature is 4.8 Kelvin. Last part from the question is to draw the graph. So first I'll be taking a T, temperature T equals 0. So the pressure P is 0 because 2.5 multiplied by 0 equals 0. When T equals 1, so pressure P equals 2.5 multiplied by 1. So 2.5 multiplied by 1 equals 2.5. And when temperature T equals 2, pressure can be calculated by the same formula. P equals KT. K is 2.5 and T is 2. Their product is 5. And for the third value of temperature T equals 3, pressure P equals 2.5 multiplied by 3. And when you multiply 2.5 by 3, the required product is 7.5. And fourth value, when T is equal to 4, pressure P becomes 2.5 multiplied by 4 equals 10. So let's write these values in the form of ordered pairs. First, when T is equal to 0, P equals 0, so I will write 0, 0. Second ordered pair is 1 and 2.5. Third ordered pair is 2 and 5. Fourth ordered pair is 3 and 7.5. And last ordered pair is 4 and 10. Okay, to plot these points, set of points on a sheet of graph paper, again we have two axes, horizontal and vertical, and I'm going to take temperature T on the horizontal axis of this graph paper and pressure P on the vertical axis. So we need to take a suitable scale, so I will take one large square equals 1 Kelvin on x-axis, so 2 large squares equals 2 Kelvin, 3 large squares and 4 large squares for 4 Kelvin. Same as on the y-axis, I'm going to take 2 large square equal to 2.5 pascals, then 4 large squares equal to 2.5 plus 2.5, 5 pascals, and then next 2 large square for 7.5, and then 5th and 6th large squares for 10 pascals. So let's join these points. First point of intersection we have at 0, 0, because when the temperature is 0, the pressure P is 0. So here is the second point of intersection for 1 and 2.5, and for 2 and 5 here we have the third point of intersection. This is the point of intersection for 3 and 7.5, and this is the point of intersection for 4 Kelvin and 10 pascals. So again, if we join these point of intersections, so we get a straight line. So this is the required graph of pressure P against temperature T.